Hello, I am Sawyer, and today I'm going to give you a brief lesson on inclined planes. So, I have a question for you. I have this 25-pound weight, and will it be easier to lift it up this climbing wall, or will it be easier to pull it up this slide? I'm going to find out. I am going to pull up this weight and time to see how long it will take. Ready? It's time for test 2. I'm gonna pull this up. Ready? Go. As we can tell from how long it took me to lift up the way up the slide and up the wall, it's a lot easier to lift up the slide. That is because the slide is a simple machine called an inclined plane. Inclined planes are just ramps, like one you would jump your bike off of, and they help us by spreading out the amount of effort or how much you have to lift up over a longer distance. Scientists and engineers have a way of measuring how much help a ramp gives us. This is called the ideal mechanical advantage, or IMA. Now on to how to calculate IMA. IMA is a very simple formula. It's just the length of the ramp divided by the height of the ramp. And if we have a ramp that is very long and not very steep, it is a high IMA. And that means it is very easy to lift something up it. However, if there's a ramp that is short and very steep, then that will have a low IMA, which means it's going to be harder to lift stuff up that ramp. So now we are going to couple of math problems so then you guys can understand it a little bit better. And I am going to go back home and show you guys how to do it. Now I'm going to do some problems on IMA. We have two ramps. They both have the same height, and one is long and gentle, the other is short and steep. Now, ramp A is 2 feet long, 1 foot tall. Ramp B, 1 foot long, 1 foot tall. And remember, IMA is length divided by height. So to calculate this, we just do, since ramp A is 2 feet long, we plug that in on top. And then since ramp A is also 1 foot tall, we put that down here. So because of that, 2 divided by 1 is 2. So A has an IMA of 2. Ramp B is 1 foot long, so we put that on top. And 1 foot tall, so we put that on the bottom. And its IMA, because 1 divided by 1 equals 1, is 1. Now, as you can see, ramp A has the larger IMA. This means that it will be easier to push stuff up it. Meanwhile, ramp B has the lower IMA, making it harder to push stuff up it. So, for those of you who are wondering why the video is still going, it's because we have plenty of things to cover, and one of those is AMA. AMA is the actual mechanical advantage, or the experimental results of how effective the ramp is. This includes friction. AMA's formula is simple. It's just the resistance force, or how much force is making it hard to move something. Divide by the output force, not output force, sorry, the effort force, or the input force. You can also call it the input force. The reason why I like to call it the input force is because it's really easy to remember it this way, because if you just erase the N, it is now I put force, or a machine puts force to move it up. Now, we're going to do a little problem to solve this. A worker is lifting a 200-pound box, so the 200 pounds is the resistance. And he is pushing it up a ramp into a truck. He is using 80 pounds of force. to get into the truck. Now, because we're dividing it up, we don't have to worry about the units. And now it's just 200 divided by 80, which is 2.5. This means that using the ramp to get the box into the truck, the ramp makes it 2.5 times more efficient. And by it, I mean the worker's effort force or the input force. The last thing we have to cover out of the math on inclined planes is efficiency. Efficiency is how effective the inclined plane is, or how much energy is left after friction is added from the theoretical. So, the formula for the percent of efficiency is easy. I'm just going to abbreviate E because I don't want to write out efficiency. It is AMA divided by IMA. And because you don't want it to be a decimal, you multiply it by 100. Now we are going to practice solving for efficiency. I've given you all of the formulas you'll need, and here is the diagram. We have a guy who's using 100 pounds of effort to push a 300-pound box up a ramp. The ramp is 20 feet long by 5 feet tall. I'll give you guys a couple of seconds to plug all of that in and solve for IMA and AMA. So now if you did it right, you should have for IMA 20 feet divided by 5 feet. Now, I crossed out both of the feet and the pounds down here because the units divide themselves out. So, 20 divided by 5 gives us an IMA of 4. Meanwhile, for AMA, we have a resistance force of 300 pounds divided by effort or input force of 100 pounds. 300 divided by 100 is 3. And now, let's plug in for efficiency. We have 3 divided by 4. So, divided by 4, which is 0.75 times 100, gives us a 75% efficiency. And that is how you solve for efficiency. One more thing you should know is that 2 other simple machines are basically just inclined planes, and those are wedges and screws. Wedges are inclined planes that are used to cut things in half, and then screws is just an inclined plane that loops around and around and around. Congratulations! If you're watching this, you have nearly made it to the end of the video. Now we're just going to do a short summary of everything we've learned today, and that is the formula for IMA is just the length of the slope divided by the height. And by the length of the slope, I mean the distance to travel. And then AMA is the resistance force divided by the input or effort force. And remember, you can always take out the N and then it's just I put force. If we have a high IMA, then it's a lot easier to lift stuff up. Low IMA, a lot harder than a high IMA. but it's still easier than if you didn't have a ramp. Now, also, efficiency, I forgot to give you guys that formula. I'm just going to abbreviate E for efficiency. It's just AMA divided by IMA times 100. And that is all. Thank you for watching. Please consider subscribing.